Okay, so this is part 2 of chapter 6, chemical formula and equations for bridging. Okay, so for students that are weaker or scored 50% and below, or 50% below 50% for your end of year exams, this video is for you. Again, we are going to just be focusing on the basics, so I hope you have watched chapter or rather part 6.1. okay. So in this second part, we are going to be describing the formula of simple compounds from the relative numbers of atoms present and vice versa, and also deduce the formula of ionic compounds from the charges of ions and vice versa. So remember, when we were talking about chemical bonding in the previous chapters, we talked about a concept called valency, and valency is referring to an element, can be referred to as the number of electrons that must be lost, gained, or shared in order to obtain a stable noble gas configuration. So again, remember what are noble gases. Noble gases are found in group 18. Example is neon, xenon, argon, things like that. Those are all group 18. They are called noble gases because they have a full valence shell. So for example, if you remember neon, okay, neon has, neon has a full valence shell. Okay, so a full valence shell refers to 8 electrons. In this case, like in what we've learned, is 8 electrons in the outermost shell. Okay, so this is a full valence electrons. Okay, the valency of an ion is its charge without the sign. So, for example, a simple one, we have sodium. Okay, sodium is 23 and a 11. Okay, so if you want to count the valence, okay, now we only have 10. Okay, wait, let me fix this. So now we only have 10. Okay, so we need to use one more electron shell, 1. Okay. So what is the valency of sodium? 1. Because this is the valency of sodium, because there is only 1 electron in its outermost shell. Okay. Go back to neon. Valency of neon 8. Valency of sodium 1. Okay, so that should be quite simple enough for to understand. Okay, so valences from group numbers. So but instead of drawing out your atomic structure every single time you want to find out the valency, quite simple enough, you can use it from the group numbers. So remember, in your periodic table, okay, across you have group 1 to group 18. Okay, so group 1 and group 2 is the simplest because their valency is the same as their group number. So group 1 includes lithium, sodium, and potassium. It is in group 1, the valency is 1. You also have beryllium, magnesium, and calcium for group 2. So their valency is 2. But once you reach group 13 onwards, okay, because of the new system of how you read periodic tables, you can just ignore the 1 at the front. Okay, so I marked the red one, you can ignore the ones at the front. Okay. Okay, let me backtrack a bit. Okay, so you can ignore the ones at the front for 3 and 4. So, ignoring the 1 in group 13, you will have 3. Okay, so your number is 3. Same thing for group 14 onwards. Group 14, 4, the valency is 4. Okay, if you do not believe me, let me draw out boron. Boron, I believe, is 775, I think. Boron, let me check. Boron is 10 5. 6, 7, 8, 9, 10, 11, 11, 5, okay. 11, 5. 10, yeah, 11, 5, yeah, I should correct, 11, 5. Okay, so boron is 11, 5. If I were to draw it out, it would look something like this. So you can see that there are 3 valence electrons. Therefore, the valency is 3. Okay, and then once you reach groups 15, 16, and 17, because they form anions, negative ions, okay, you have to, again, same thing, ignore the number 1, and then you take 8 minus 5, 8 minus 6, 8 minus 7 to get the valency. Why 8? Because again, remember, 8 is the max number of electrons in the outermost shell. So you take the max number, you take 8 minus 5, so you are left with 3, 2, and 1. These are the valence electrons, or rather the valency. Okay, valency. So they can receive 3, 2, or 1 electrons to form ions. Okay, alright, because they need to gain 3, 2, or 1 electrons to form their anions, their negative ions. Okay, previously when we were talking about groups 1, 2, 3, and 4, they tend to lose electrons. Therefore, their valency is 1, 2, 3, and 4 respectively. But in this case, gain 1, 2, or 3 electrons. That's why their valency is 1, 2, and 3 respectively. Okay? So we also have something called transition metals, which we covered in the previous part. Okay, so transition metals can form more than one stable ion so that they have variable valences. Okay, so for example, we have iron 3, which means it forms an iron 3 plus. Iron 2, it forms an iron 2 plus. Copper 2, it forms a Cu2 plus. Copper 1, it forms a Cu plus. And this is IV. IV is 4, Ti4 plus. One more thing to take note, okay, always write down your numbers first before your charge. Okay, so it's not plus 3, but rather it is 3 plus. Okay, this is wrong. Okay, Fe plus 3 is wrong. Okay, so write down 3 plus. Valency of ion as well, because it loses 3 electrons. This one loses 2 electrons. Okay, so on and so forth. Okay, so this one should be quite simple to understand. Okay, there are also fixed valences. Okay, just need to recognize them. Just know that these two, they are fixed even though they are considered transition metals. Okay, it's Zn2 plus and Ag plus. Okay, or silver plus. Okay, this one is where some of you got confused. Okay, we're talking about polyatomic ions. So you have all of these are polyatomic ions. Need to memorize, because nobody's gonna help you. If you don't know, really very difficult. Even I cannot help you. You have to memorize your ammonium, hydroxide, nitrate, sulfate, carbonate, and phosphate. Okay, they are polyatomic ions because they contain more than one atom covalently bonded together. So remember, in your end of year exam, I think there is one question, right? Sorry, end of year exam, or I think it's in your worksheet, your current worksheet that I've given you. Okay, there's one question. Which one contains a salt that contains covalent bonds as well as ionic bonds? Okay, so you can see here these lines here, these are covalent bonds, but together as NH4 they form an ion with a plus charge, and this plus charge will be the one that is used to form the ionic bonds. Okay, all right. So again, to understand the valency of the ion, just take a look at the charge. Just remove the plus and minus sign, so you get NH4 plus. Valence is 1, because again we don't show the 1, it's 1 is there. Same thing here at OH1 minus. Okay, we don't show the 1. Okay, then for carbonate you have 2 minus, so the valency is 2. 3 minus, the valency is 3. Just remove the charges, or either the plus and minus signs. You will find out the valency already. So now let's deduce chemical formula of compounds. We can cross multiply the valences of a chemical species and compound to deduce its chemical formula. Okay, we've done this before. I'm gonna quickly run through it. Okay, so basically you have magnesium and chlorine. Okay, we know that magnesium is from group 2, chlorine is group 17. Okay, so it has a valency of 1, it has a valency of 2. Okay, so quite easy, you just cross. Okay, so Mg will form a 2 plus, Cl will form a minus. Take the coefficient. Okay, you can do either way lah, the one the textbook show you or my way. So Mg1, Cl2. Again, do we show the 1? We don't show the 1, so we ignore it. So it'll be MgCl, let me rewrite Cl2, something like that. Okay? So let's take a look at this question. Deduce the chemical formula of sodium phosphate. Sodium is in group 1 and has a valency of 1. Phosphate ion has a valency of 3. Okay, so you just cross multiply, so you'll get Na3PO4. Okay, so these are the 3 different steps you need to know. Step 1, determine the ions in the compound. Step 2, determine the charges. Step 3, determine how they would cancel each other out. So let's try. Okay, deduce the chemical formula. Sodium oxide, the cation is sodium. The anion oxide is O2 minus. Okay, so if I want to do the working, it's Na plus, O2 minus. Take the coefficient, so this is an invisible 1, we don't show the 1. Okay, so we cross, take the coefficient 2, you'll get Na2O1, but we don't put the 1 again, we just remove the 1. So it will be Na2O. Next, magnesium chloride, Mg2 plus, Cl minus. Same thing if you want to do your working here. Okay, just take the coefficient cross. This is invisible 1. You don't write down Mg, Cl2. Then you have aluminum or aluminum. Take note the valency of aluminum is 3, the valency of sulfate ion is 2. So if you want to do the working as well, just cross, you'll get Al2SO4. Is it just like that? No. Remember, you need to put in your bracket 3. Okay. So remember in your previous part 6.1, okay, this 3 represents 3 sulfate ions. Okay, as a whole, it's 3 sulfate ions. Excuse me. Alright, so that should be quite easy enough, right? If not, okay, you can pause the video here, watch again, and try to decipher it on your own. Okay, so we want to deduce the charges on ions from chemical formula. Why is the overall charge 0? Remember, compounds are electrically neutral. Means their overall charge is 0. Okay, when their overall charge is 0, okay, it means all the ions cancel each other out completely. Okay, and from there you can find out the overall charge. You can find out the charge of an unknown ion. So in this case, we are trying to find the unknown ion, the charge of this unknown ion CO or cobalt. We know Cl2 is Cl minus. Okay, and there are 2 of them, so the total charge is 2 minus. Okay, so this is the charge of Cl ion. Okay, and then this 2 represents the 2 chloride ion, and then again you do your mathematics, you'll get x equals to plus 2. So again, this is the final summary for this part. Take note, the number of electrons must be lost, gained, or shared in order for the element to obtain a stable noble gas electronic configuration. The valency of ion is its charge without the sign. You can cross multiply just like I've shown you, and also you know the individual ions, how to deduce the charges of individual ions by looking at a compound. Okay, since compounds are electrically neutral, they are 0. Okay, you can click on to the next video to watch the next part, the last part of this chapter.